Namaste friends, this is Mandar Bhanushe and we are back with the next video lecture on sketching of linear inequalities. In the previous video, what did we see? We have seen how to draw linear equations on the graph paper on the xy plane by 3 steps. Just to revise, step number 1 was to identify 2 points on the line. In the second step, we plot the 2 points on the graph paper, and the third step was to connect these 2 points with the scale, and that becomes the graph of the line. In this video, what we are going to do is to sketch linear inequalities. For solving linear programming problem, the most important thing is to sketch the graph of linear inequations. So let us start sketching of linear inequations with 2-3 examples in this video, and in the next video we will be seeing how to solve linear programming problems graphically. So let's begin. So here are some examples in front of us. We have taken 4 examples which we are going to do in this part. Let us see, we have, say for example, we have to draw the sketch of the linear inequation x less than equal to 5 or x greater than equal to 8, y less than equal to 4 and y greater than equal to 7. We will do these 4 examples here. The first thing is, let us go back. In the previous video lecture we have seen this graph of the line x equal to 5. So we have already seen how to draw the line x equal to 5, and this is the line x equal to 5 as you can see on the graph paper. What we have to do is we have to draw the graph of x less than or equal to 5. Less than. So on the number line we know that the numbers up to the right of origin are 1, 2, 3, 4, 5, 6, 7, 8 in this order. So when we want less than 5, it means on this number line here we have to go to the left of 5. That is the simple meaning of that. So the graph of the line linear inequation x less than or equal to 5 will be a region. This is very important to understand, that the graph of linear inequations is a region, and the region depends upon whether, now this line is this vertical line x equal to 5, so the region will be either to the left or to the right. We want x, values of x which are less than 5, which will be to the left of 5. So therefore the region will be this region. So this what I am drawing right now, this is the region representing what? Representing x less than equal to 5. So this what I have drawn on this graph of left of this linear inequation x equal to 5. This represents x less than equal to 5. So if you want to sketch the graph of x less than equal to 5, this is the sketch of that. Let us take the example of the region x greater than equal to 8. For that we need to first draw x equal to 8. So let us draw the line x equal to 8. 8 is here as we see here. So we have to just draw this line x equal to 8. So this is a line here. This is a line representing equation x equal to 8. And what is the sketch which we want to draw? We want to draw x greater than or equal to 8. So greater than means it will be to the right of this line, and therefore this region representing x greater than or equal to 8 is this region. And you can see I am drawing the sketch which is of having both the of all quadrants, okay, both this positive quadrant as well as the negative quadrant. This on the right of x equal to 8 is the region x greater than or equal to 8. So what have we understood from this? We will do 2 more examples. That sketch of linear inequation is a region. It is a region which the line divides the plane into 2 parts. So either it is to the left or to the right, or if it is a slant line, we will see examples of that also. Very simple and easy to do. You have to just use your simple logic of the numbers which are there on the xy axis. Let us take the example of linear inequation. Let us say we want to draw this y less than equal to 4. So let us take this example. So first we need to draw where is y equal to 4, right? So this is your x axis, the y axis, this is the origin O, and suppose this is a point 4 here, right? And this represents 0, 4, So where will be your line y equal to 4? So first is to draw the line. So this is the line. This line is y equal to 4. And what we are asked to do, we are asked to find out the region representing y less than 4. So on this y-axis, numbers which are less than 4 are to the bottom of this line. This is the part. So let us draw it with different color. So this, what is representing towards the down, this is the region which is representing y less than equal to 4. So what is this region? This is a region y less than equal to 4. And though I am drawing the arrows like this, it is actually the entire region below this line, whatever comes below this line. So arrow indicates you can go down in this direction more. Okay. So this is y less than equal to 4. Let us do this example of y greater than equal to 7. So now we have greater than equal to 7. For that, first we need to draw what is y equal to 7. So let us draw first what is y equal to 7. Let us say this is 4, so 5, 6 and 7. So this is the point 0, 7. Let us draw this line. This is the line y equal to. And now what is the sketch we have to draw? The sketch which we have to draw is y greater than or equal to 7. Greater than or equal to. So the line is included. In addition to that, numbers which are greater than 7. Where will be the numbers greater than 7? It will be on the top of the line. So this region here represents the region is y greater than equal to 7. And you can see I am drawing the line from the point on the line because there is an equality also here. So this is a region which is representing y greater than equal to. So what we have seen, 4 examples of lines which are parallel to x-axis or parallel to y-axis. We'll see 2 more examples where there are equations and linear inequations which are not like x equal to something or y equal to something, but like ax plus by equal to c in this format. And then we'll draw the sketch of the region representing that linear inequation. So let us do that. So here is an example in front of us, and the example is to sketch the graph of the linear inequation x plus 3y greater than equal to 9. The first few steps are same, so I am skipping those steps. Step number 1 is to actually identify the points. So we have made this table here, and then we have to plot those points. So we have already plotted the points. Let us draw the line representing the equation x plus 3y equal to 9. So just connect these 2 points and draw a line which passes through these 2. This line which we have drawn is the line representing the equation x plus 3y equal to 9. What are we supposed to sketch? The inequation, and the inequation is greater than or equal to 9. So always remember that the greater than region will be the region above the line. So in this example, you can see this is the line representing x plus 3y equal to 9. So region above that will be this region. So this which I have drawn with the red color, this is the region representing x plus 3y greater than or equal to 9. This is the sketch of that. If instead of this, had I asked this region as x plus 3y less than or equal to 9, if this was the region, then what would be the sketch of that? The line is this x plus 3y equal to 9, less than means below the line. So if I have to draw this, this is the line, this is the region, and I am drawing the region with the point on the line because we have this equality symbol also there. So this region which is below this line, this represents the region x plus 3y less than or equal to. I hope this is clear to you. We'll do one more example which is related to solving linear programming problems, because in a linear programming problem we have not only one linear equation but we have more than one linear inequations. So now let us do an example where we have 2 linear inequations along with the non-negativity constraint. If you remember what we have done in the previous video on LPP, x greater than equal to 0, y greater than equal to 0, these are the two non-negativity conditions. So we'll use these two and two linear inequations, and we'll see how to draw the sketch of such a linear inequation where we have not one but more than one linear inequation. So let us do that. So here is an example in front of us where we have three linear inequations, in fact two linear inequations, and the third one is the non-negativity constraint. The first one is 2x plus 3y less than equal to 12. The second inequation is x plus 4y less than equal to 8. And the third is the non-negativity condition of the linear programming problem, x greater than equal to 0, y greater than equal to 0. In our understanding, we should always remember the non-negativity condition means the graph is only in the first quadrant. Okay, so both x and y values are non-negative. So that is this first quadrant which you see of the xy plane. That is what the non-negativity condition means to us. So what remains to do is to plot the equations which are given as constraints and then the graph of the linear inequations. The common of the both linear inequations, the sketch of which is common to both, that is the region where we are going to find the solution of the linear programming problem. So I have already worked out because it is already what we have done in the previous video lecture. So for 2x plus 3y equal to 12, we have the points 0, 4 and 6, 0. So this is 0, 4. Let us call this as point A. Then we have 6, 0 here. Let us call this as point B. For x plus 4y equal to 8, we have 0, 2. Let us call this as point C. And we have 8, 0, which is as point D. We'll draw both these lines now. So 0, 4 and 6, 0, that is what we have to connect. So 0, 4 connected with 6, 0, and this is the line representing 2x plus 3y equal to 12. Let us call this as line L1. So I'll just write it down like this, L1. And we have x plus 4y equal to 8, where we have to join 0, 2 and 8, 0. So this is 0, 2 and 8, 0. Let us draw a line passing through these two. We have this as say L2. Now once we have drawn these two lines, we have to sketch the region which is representing the inequations. Let us do for the first one. So we have first one, 2x plus 3y less than equal to 12. So less than, as I said, if you remember, which is below the line. So 2x plus 3y equal to 12, this is the line 2x plus 3y equal to 12. This is the line 2x plus 3y equal to 12. Less than that, so we have to go below. So and we have to be in this first quadrant only. So our consideration is only in the first quadrant. So we will not go to the negative quadrants. So what is the region which is below this line, which is in the first quadrant? It is this region. Okay. So this is the line L1 which we have, and I am not going to the negative quadrants because we are only focusing on the first quadrant. This is below L1. Then which is the region which is below L2? Why below? Because again this is less than equal to, and less than equal to means the region which is below the line. And this is your line L2. This line L2 is x plus 4y equal to 8. We want less than equal to 8 and in the first quadrant. So let us look at the first quadrant. So this is the first quadrant. So if I just draw the lines like this, this is the region which is below the line L2. What we are supposed to find? Common region. So which is a common region which is which is below the line L1 and also below the line L2. The common region which you can see here is, let me use another color here. So this is the common region, as you can see. This is the common region here. And if I want to just highlight it, you can go it like this. Just from here, here, and then this line, and then this intersection, and this. Let us call this one more point of intersection as point E. So the region representing O, C, E, B, this region is the region which is common to linear inequation 1, linear inequation 2 and the non-negativity condition x greater than equal to 0, y greater than equal to 0. So when you are solving LPP problems, this is what we are going to do. The region which is common to the linear inequations. So I hope you have understood this concept of sketching of linear inequations and then finding the common region between the linear inequations. In this video, we'll stop here right now. I've given some problems for you as an exercise in the description. In the next video, we are going to see how we can solve a linear programming problem using this graphical method. The basics are same. We have to draw equations, then sketch the graph of linear inequations, the region, then to find the common region, and then whatever are the extreme points of the common region, we have to evaluate the linear programming problem objective function on those extreme points. We'll see it in detail in the next video lecture. Thank you for watching. Namaste.